Okay, so in this video we're actually going to work through some practice problems from the math section, and in the meantime, while we do that, we're going to talk about some general strategies about how to approach this section and how to approach particular questions. Before we start, I want to talk about pacing and omitting. How many should I omit is a question I get a lot. And it depends on the section, depends on your score goals, but this is the general guideline that you can use if you want to figure out how many to omit for the math section right here. So let's pretend for a minute you want to go for a 500. This means you can omit 8 per section. So that means in the 20 question section you're going to do 12. In the 18 question section you're going to do 10. In the 16 question section you're going to do 8. Okay? Let's say you're shooting for 600. There you can only omit 4 per section. So instead of 12 you're going to do 16. Instead of 18 you're going to do 14. Instead of 16 you're going to do 12. If you want to go above 700, then you're going to really have no room to omit anything. In that case, you're going to want to, if you are trying to go for 700 and you're not quite sure on a question, you want to guess. But this is going to be the general approach you want to take. Now, this is going to be the number of questions you do without guessing. That would presumably be the most ideal solution here. Now, if you need to guess, of course, you can do it to reach this pacing goal, but in theory, you want to do this without guessing in order to maximize your chances of getting the score. The other thing is, well, what kind of questions are you going to do? If you're doing 12 questions, let's say, that means you really only need to do part of the first 2/3, so pretty much the easies and the mediums. You don't really have to touch the hards. In fact, unless you're going for a 550 plus, you really don't even need to look at the hards to get the score you need, assuming, of course, you get all the easies and mediums right. So that's why, again, you want to focus on the easy and the medium questions first before you start worrying about those hard questions. Too many people spend way too much time on the hards. They'll rush through the easies. They'll rush through the mediums, all in an effort to get to the hards to try to pick up points here. But listen, if you rush through the easies and mediums, you're probably losing points either because you don't spend enough time to figure out a question, or because even worse, you make a dumb mistake. So really what you want to do is focus on the easies and mediums first. Try to get as many of your budget done here before you move to the hards, and then you can go ahead and see if you can pick up extra points. Again, if you're going for 700 plus, even a 650 or 600 plus, you're going to have to touch on some of these hards. But for those of you who are getting less than a 600, if you're spending a lot of time on hards, you're doing yourself a disservice. So let's move on now to some general questions to do. And each of these questions I'm going to give you a general strategy that you can use to approach this section. The first strategy is slow down and read. You'll remember in video 3 I mentioned that the math section is as much a test of reading as it is a test of math. It's as much a test of your ability to read a question, figure out what they're saying, figure out what you need to do, and then finally executing that with the actual math. So notice the main 2/3 of that is reading it and figuring out what's going on. Sure, you got to do some math in the end, but as you're going to see, the math is going to be relatively straightforward, especially compared to what a lot of you are doing in your math classes regularly. So let's look at this first question. The figure above is composed of 25 small triangles that are congruent and equilateral. All right, stop. Stop right here. 25 small triangles. So here are the 25 small triangles. They are congruent and equilateral. What does that mean? Well, congruent means all equal. So that means these triangles are all equal to each other. Okay? And they're equilateral. So that means each of these triangles has equal sides. Right? All 3 of these sides of each little small triangle is equal. Okay. If the area of DFH is 10, all right, so triangle DFH is this one. And the area of this is 10. Okay? What is the area of AFK? So that's the entire triangle. All right, well, you might think, oh, we need to do some sort of, figure out what the height is, figure out the base, do some multiplying, if this is 10 and the base is blah, 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 maybe call this X. You could do that, but that's awful. Let's instead look at what they're telling us. They're saying that this triangle here, the area is 10. Well, how many little small triangles are in this big triangle? Well, I count 1, 2, 3, 4. So that means 4 small triangles make up an area of 10. Well, how much when would each triangle be? They're all congruent and equilateral, therefore each triangle contributes equally to this 10. So to figure out the area of one individual triangle, we say 10 divided by 4, right? The area divided by the number of triangles. So 10 divided by 4, we pop that into our calculator, and let's see what we get. We get 2.5. Okay, so if the area of a small triangle is 2.5, and we know we have 25 of them, we're just going to do 25 times 2.5, and that should give us the area of this entire thing. 25 times 2.5 gets us 62.5, and that's choice E, and that is the answer. So as you can see, what we did is we really slowed down, we read it, we read every word, because every word counts. Just like in the reading, how every word counts, we'll talk about this in a little bit. In the math, every word is going to count. So you really want to slow down, pay attention, and read very carefully. A similar strategy is write everything down and do nothing in your head. I see too many students trying to do things in their head when they should be either writing it down on paper, putting it in their calculator, doing anything else but just kind of sitting around and trying to figure it out in their head like a math whiz. Most people who are good at math are not good because they can do it in their heads. They're good because they know how to use the tools at hand, aka a paper, pencil, and a calculator, to delegate some of that thinking to the paper. So let's look at this one. An isosceles triangle ABC above. Okay, so we know this is isosceles. That means this side equals this side. Also, this angle equals this angle, because the base angles are equal and the two sides are equal. AM and CM, so AM and CM are the angle bisectors of angle BAC and angle BCA. So what does angle bisectors mean? Well, that just means that this segment AM bisects this angle into two equal pieces. So that means that this angle equals this angle, and this angle equals this angle. And as well, all four of these are equal because the original big angles were equal, and you're just splitting two equal angles into two smaller equal angles. What is the measure of AMC? So now this is what I mean by writing everything down. We're kind of keeping track of everything that the problem tells us onto this diagram. We could redraw the diagram if we want, but for now I'm going to use this. And then we just kind of work here and see what happens. Well, we know this, we got a big triangle here, right? It's isosceles, means this angle equals this angle. We know there are 180 degrees in a triangle. So how many degrees are left over then? We got 40 here. That means 180 minus 40, that's 140. That means these big angles here must add up to 140. Now, if they're equal, we can divide it by 2. We see that each of these guys, each of these big guys, is 70. 70, 70. Now, we're looking for, by the way, we should have marked this earlier, we're looking for AMC, which is this angle right here. So, we need to find this triangle, essentially, to figure out what this is. Well, we know this big guy is 70. Then we know these are bisected, so we can split this into 35 and 35, 35 and 35. What do you know? We have now this angle and this angle, right? We've got this guy and this guy, which is 35 and 35. That's 70, which leaves what left over for him? Well, it's 180 minus 70 is 110. So there's your answer, A, 110. So let's move on to another strategy, and let's use the answer choices. Since this is the multiple choice section, we should be using the answer choices either by testing the answer choices, or in this case, testing our own numbers, in order to kind of beat them at their own game. We want to try to avoid doing algebra when we can, just because it can get confusing. So let's look at this example. A boat costs X dollars, and this cost is to be shared equally by a group of people. In terms of X, how many dollars less will each person contribute if there are 4 people in the group instead of 3? Okay, so when I look at a problem like this, and I see a couple things. I see X in the question. A boat costs X dollars. It could be P, J, doesn't matter. It just has to be some kind of variable. I also see in terms of X in the question. And then I also see, most importantly, the answer choices are variables. They're X's. They're not numbers. When I see that, it's a hint to me that I'm going to want to plug in my own number here. So I want to put in my own number for X. And that will help me figure out what the answer is going to be. So let's see. A boat costs X dollars. And this costs to be shared equally by a group of people. How many dollars less will each person contribute if 4 people in the group instead of 3? So we have a boat that costs X dollars. It's being shared either by 4 people or by 3 people. So let's pick a number for X. We can pick any number. We can pick 100. We can pick 4. We can pick 63. It really doesn't matter. But I want to pick a number. It's going to work either way. But I want to pick a number that is just easy to work with. That's divisible by both 4 and 3 just for the purposes of this problem. So let's pick 120. Now again, you could use 100. The math is a little bit weird, but still I'm going to use 120 just to make the math easy. So what do we do? Well, the boat costs X dollars. How many dollars less will each person contribute if there are 4 people in the group? Well, if there's $120 for the boat and there are 4 people, each of them are going to pay how much? Well, $30, right? If there are 3 people in the group, we're just going to do 120 divided by 3, and that's $40. Well, notice there's a difference here, right? When there are fewer people, they pay more. When there are more people, they pay less. That's obvious. Well, what's the difference? The difference here is just $10. So this is the number we need to look for. This is our answer, right? This is our answer to the question, with our number being 120. Well, let's go to the choices and put in 120 for x and see what equals 10. Well, 120 divided by 12, that's just 10. Check. Now we're always going to check the rest just to make sure there are no copies. 120 divided by 4, that's 30, no good. 120 divided by 3 is 40, no good. 7, I know this is not going to work, but we'll check it anyway. 7 times 120 divided by 12 is 70. That's not equal to 10, no good. And 7 times 120 is not going to be equal to 10. So our answer here is A. And there we go. That's pretty much testing your own numbers in a nutshell. Now again, if you had gotten more than one answer, let's say we tested this and we got A and D, you just plug in another number and you'd eventually narrow down to the one that was the answer. And again, this will work with any number you put in. I just put in 120 because you can see the math is easy. But if you used 100, if you used 4, it doesn't matter. You just do the subtraction and plug in your own number here, and you're all good. Now, on geometry questions, you can do what's called ballparking, and that's essentially estimating, looking at a picture and making estimates based off of the lengths of things, the sizes of things, the relative sizes of things, and that's what we can do on this problem here. In the figure above, square RSTU is described in the circle. What is the degree measure of arc ST? So that's this. So we need to find out the degree measure of this guy. Now, if you look back on your reference table, your information at the beginning of the test section, you'll see that every circle has 360 degrees of arc. So let's take a look at this arc segment here and say, well, what size do you think? What piece approximately of the entire circle do you think this is? To me, it looks like a quarter, right? So we can take a quarter, 360, that's 90. So this should be about 90 degrees. Well, let's look at the answers here. Well, it's not 180. That's half the circle. Certainly not 120. That's a third of the circle. 90, that looks good. 60, I mean, that would be pretty small. There are 4 pieces here. And there are 45, now it's even smaller. So I think C is the answer, and it turns out that it is. C is the answer to this question. So here's an example of you don't even have to do any math. You can just take a look at the picture and ballpark based off of the size of the relative pieces and what you're looking for. Now, ballparking works. Let me just move over to the next side of this. Ballparking works on geometry questions except when it says not drawn to scale. And this is what we kind of mentioned briefly in video 3. You'll see it here, figure not drawn to scale. What they mean is that you can't look at this and make any judgments based off of relative sizes. So in this problem, it looks like, for instance, x, y, x and the y angles are all equal. But since the figure's not drawn to scale, we can't assume that. We can't assume that x is equal to y. We can assume, of course, that these 3 y angles are equal, and that will be important for this problem because they all have measure y, but we can't assume anything about the relative sizes about x and y. So when this happens, we just have to do the math. In the figure above, point B lies on AC, okay? X and y in integers, okay? Which of the following is a possible value of x? So they've got to be integers, so they've got to be whole numbers. They can't be decimals or fractions. Well, this is an example of one where we can take their answers and test them. So instead of putting our own number like we did on one of the problems before, we're going to use their numbers and test. So if x were 30, what would be left over for these 3? Well, we know the number of degrees in a line like this is 180. So if 30 were used here, that would leave 150 for these 3 angles. We know that they're equal, so we better be able to divide 150 by 3 and get a whole number or an integer, and we do. So each of these would be 50. So this looks like a pretty valid scenario, so we're going to keep that. Let's test 35. If x were 35, that would leave 145 for these 3 angles. 145 divided by 3, however, when you pop it into your calculator, gets you 48.33 repeating. That is not an integer, so this cannot be a scenario that will work. And if you go ahead and test C, D, and E, you'll see that you'll never get an integer. You'll get some sort of fraction or decimal. So that means the answer here has got to be A. Now let's move on briefly to the grid-ins. There are special directions associated with the grid-ins I just want to mention briefly. First things first, you can either grid in, if you have a question, you can either grid in the fraction answer or the decimal answer. In this case, those aren't equal, but let's say you had, 1/2. You can either grid in 1/2 or 0.5. And you grid it in, as you can see here, you can put the decimal wherever, you can start wherever, you just fill it in, you bubble in your choices, and you're good to go. Let's see if there's anything else that's important. Mixed numbers, be very, very careful about mixed numbers. Let's say you have 3.5, as they have here. You've got to grid that as an improper fraction, 7 halves, or as a decimal, 3.5. If you grid it in 3 1/2, that looks like 31 halves. So just be very careful with mixed numbers. Oh, in general, I like sticking with fractions. They're easier to work with than decimals. You don't have to worry about rounding. So in general, I'd say stick with the improper fractions if you can. And then the final point is decimal answers. If you do get a decimal answer like 0.66666 repeating, you can't do repeating. So you either got to enter the fraction, which is 2/3. Then if you want to enter the decimal, you can either do the decimal and truncate, that is, you just slice it off and just grid it in where it ends, or you can round up. So you can do 0.667 and then you're good. Let's say you had something like 0.4444. You can only grid that as 0.444, obviously, because you don't round this up to 0.445 because this is a 4. So that's the general rules for the grid-ins. Let's take a look at some practice grid-in problems. And now the thing with the grid-in section is a lot of the strategies that work for the multiple choice do work here. Some don't. Obviously, the plug-in answers don't work because there are no answers. But I'd say the main strategy that works here is just reading carefully, reading very slowly, and trying to figure out what it is that they're trying to say. So let's look at number 12. The price of a certain item was $10 in 1990, and it has gone up by $2 per year since 1990. If this trend continues, in what year will the price be 100? All right, let's break this down. In 1990, the price was $10. The price goes up by $2 per year since 1990. So in 1991, the price would be 12, right? In 1992, the price would be 14, and so on. All the way down to some year where the price is 100, and we're interested in what this year is. Now, let's say to ourselves, well, how many dollars do we have to get between 10 to 100? Well, let's say 100 minus 10. That's $90 of difference. We need to gain $90 from 10 to get up to 100. Well, if we gain $2 per year, how many years will it take us? Well, we need to get $90. It's $2 per year, so we just do 90 divided by 2. That's 45 years. If we start in 1990 and we add 45 years, we get the year 20,000 or 2035. And that's going to be the answer. So when we do our grid in, we're going to grid in 20, 30, 5, and then you do your little, whatever the grid in is here. And that's your grid in. Let's look at number 17 here. Tom and Allison are both salespeople. Tom's weekly compensation consists of $300 plus 20% of his sales. Allison's weekly compensation consists of $200 plus 25% of her sales. If they both have the same amount of sales and the same compensation for a particular week, what was that compensation in dollars? So this is a very long one. It's a 17, so this is a very long one, lots of stuff going on here. We really need to break this down piece by piece. Tom's weekly compensation consists of $300 plus 20%. I'm going to write that 20% as 0.2 times his sales. So 20% of his sales is just 0.2 times, we'll call that S. So that's how much he gets paid per week. Allison, that's Tom. Allison, on the other hand, gets 200 plus 25% of her sales. So that'll be 0.25 times her sales. Well, we have Tom and Allison here. They tell us first that the sales are equal, the same amount of sales. So S equals S. So we're going to use the same S for both. And they have the same compensation. So remember, this is the compensation, right? This is how much they make per week. If they made the same amount, then what we can do is make them equivalent. And now we've got an equation that we can solve. We have 300 plus 0.2s equals 200 plus 0.25s. So let's subtract 200 from both sides. We get 100. And let's subtract 0.2 from both sides equals 0.05s. Now I'm going to divide both sides by 0.05. And I'm going to get my S is, hold on, 2,000. Now, is that our answer? Do we grid that in? No. This is something that will happen often. Make sure you give them what they want and don't grid in something that's not the answer. What we need is the compensation that they had. So we need to take this S and plug it into either one of these equations to get the C, compensation. So let's do Tom. 300 plus 0.2 times 2,000. So I'm going to plug that all in. 0.2 times 2,000 is 400. We add 300 to that. We get 700. And that's going to be our answer. If we plugged, by the way, 2,000 in for Allison, we should get 700 as well. So our answer is 700. We're going to grid that in. So that's basically the run through of the math section of the SAT, general strategies. I hope this was helpful. In the next section, we're going to start looking at the reading, the critical reading, both the sentence completions and the reading passages. If you liked what you saw, please rate, comment, and subscribe to this channel. There'll be much more to come. Also, check out my website if you'd like to find more videos and more information on how to beat the SAT. See you in the next video.